Hello, everyone. Today I am going to talk profiling your Gadget apps. So profiling will allow us to look at the CPU time and memory used by our actions and routes. I'm going to focus on CPU time. Let's go ahead and get started. So I've got this app here. Let's say this is my app I want to profile. I have called it profiling. And I've got a couple actions I am going to look at. I am not going to look at superfakelongrun.js, but I have two common use cases that we often see cause slowdowns and take some time. So they're good candidates for using a profiler. I've got image. Well, this generates an image. It's an action that generates an image, but often it's image manipulation when you're going through pixel by pixel and doing something to an image. In this case, there's a bunch of transformations that I'm applying to an image that I am generating. So we're gonna use a profile to look at this. The second action is generating a report from Shopify data. Now this one is gonna be a little more interesting because it actually isn't a super long running action, but it lets us look at some interesting things in the profiler that I'll point out. And there's some interesting solutions for the Shopify report use case or just any report use case as well. So let's go ahead and get to it. First thing I'm gonna do is, if I haven't, I need to install Gadget's command line, GGT. I've already done that, so I am just gonna go ahead and copy this command and start the GGT dev command. What this will do, should probably be in the proper directory. There we go, let's do this. So this will bring my Gadget project down to my local machine. So you can see here, just pulling files down. If I go into my directory, I've got my API, my web folder. All of the files I see here in my web editor are now local, and I can go ahead and do something like pop this open in my favorite editor. Come on, cursor, I believe in you. Let's make this bigger and pop that open. I'm not going to be using the AI agent today. So you see here, it's the same directory structure here in Cursor. So my Gadget project has been pulled down locally. If I flip back to my terminal, we recently released a GGT debugger command. So what I can do is go ahead and run this, and you can see it opens a WebSocket connection to localhost 9229. I can use this connection to go ahead and debug. I can use any VS Code based debugger like Cursor here, run and debug, to go ahead and if I run this configure command, I will get files and I'll get a profile here, and I'll be able to set breakpoints in my actions and routes and actually go through the debugging process. But I can also use this connection to profile, which is what we're here to do today. So, whoa, go away. Just upgraded to the latest Mac OS, so I might get some weird pop-ups here. So what I need to do is I'm going to use Chrome's DevTools to go ahead and profile. So if I go to Chrome //inspect, I'm brought here to this page, and I can see that I've got this remote node target. I've got my node version. I've got my localhost 9229 here. If I click inspect, it will actually go ahead and open the profiler for me. And you can see I've got my console, my sources, kind of what I'm used to seeing. What I'm most interested in actually is this performance tab. So we can see here, node performance, and I've got a record button. So I can go ahead and record the amount of, it is going to measure CPU time spent in my various actions and routes. Now let's talk a little bit about the node profiler. It's a sampling profiler, which means it is taking a bunch of little snapshots through this recording process. Because it's sampling, it is very possible that functions, utilities, calls are completely missed, especially if you're only running your action once. So if you try running an action once, record that profile, run your action, stop the recording, you might not get a picture of everything that ran. Chances are you won't get a picture of everything that ran, because it is just sampling. It's not doing like a tracing based profile. So that means in Node, what you typically do is run the same thing over and over and over again, and you get a representative sample of the average run of your action or route or function in this case. So let's flip back to my Gadget project. I'm just gonna use the API playground here, and I want to run in action multiple times. So if I do, just going to use an array. I'll just run an action 100 times. And I will start with my generate image action. So I'm going to run my action 100 times. My profiler is going to run for that entire duration, and I should get a representative sample of all of those runs. So let's go ahead and do that. Let's press record. Go ahead and start this. And now we wait. And once this is done running, it should only take a minute or so, I'll go ahead and start exploring the profile. There we go. So it's finished. It ran 100 times. I can go ahead. Oh, only 30 seconds. Look at that. And this is what we get. This shows us, we can see it. It looks like the same thing 100 times because that is what it is. I can go ahead and if I really want, you can focus on a section of this. Now, because you're profiling the entire Node backend, that's going to include some of the Gadget framework pieces that are set up for you. The key thing to look for, especially for actions, profilers are going to record individual functions. So one major tip when you're going to profile an action or a route, it's going to show functions in here. You can see I've got my run function from my action. I've got apply Gaussian blur, which I can see is taking up a lot of time. Apply sharpen filter, edge detection. If I actually go back to my action, my generate image, those are all functions. You know, there's my run, generate the image, apply the blur, sharpen, edge detection. These are all individual functions that are being recorded in my profiler. So it's very useful instead of having one big run function. If I just had all my logic in a run function, I would just see this top bar run here. Would not be very interesting. I might get some additional calls down here if I'm using utilities or third-party calls. It is going to record that as well. If I have any expensive crypto or JSON string transformation functions, I might see some of that, but ultimately, if I'm not breaking down my actions and routes into functions, then I'm just going to get one big bar. It won't be super helpful. So it is important to break down and have smaller functions because that allows you to dig into them. And once again, looking at any one of these individual runs, it might not be a complete picture. It might miss some things. This, I think, is a pretty good picture because it actually samples the functions fairly well. But anywho, I'm going to space back out here and look at the complete view. I'm going to bring up this bottom section because this is actually a little more interesting for us. And I'm going to click on the bottom up view. So what this is going to do is this will give us our functions that ran and their parents. So it's bottom up. So I can see apply Gaussian blur. It was called by run. Now, generate synthetic image is also here. Make this a bit bigger, maybe. There we go. I think this is just due to the sampler. Generate synthetic image does not call apply Gaussian blur. We can go back and check that in our code if we want. I think this is just due to the sampling nature. It gets a little confused. It doesn't build the tree correctly all the time. We can see that the majority is the run function though, and that is okay. But we can see apply Gaussian blur is taking the most time. We have a self time and total time. Now, these are both measuring CPU time. Self time is the amount of time spent doing work within that function itself. So in apply Gaussian blur, if I flip over, let's take a cursor here. So if I go to my apply Gaussian blur, I am doing a whole whack of work. And if you don't know what a Gaussian blur is, it's just a blur. And how you can apply this, well, I'll talk about how it's applied in a little bit. I'll give a quick overview. But you can see we're doing a bunch of work. We're not calling external functions. We're like looping through all of our pixels, and it's not a very efficient algorithm right now. You see I've got a stubbed out, more efficient version, but this is kind of the work we're doing right now. So self time is all of that work. Total time is the amount of CPU clock time spent in that function or any of the functions it calls. So if I'm calling utilities from apply Gaussian blur, that would also be captured in total time. And run, my root action file is the best place to look at this. So I can see that there is a long total time here in my run function, but self time is relatively short. So there's a big discrepancy. So when I am looking for functions that I want to optimize, that I want to speed up. Self time is typically what I am going to focus on as opposed to total time. And it is useful to see this tree because if I am calling apply Gaussian blur from multiple places, I'm not. But if I was, maybe I can reduce the amount of times that it's called. We'll talk about strategies for optimizing a little later. So I can see apply Gaussian blur is taking a long time. I've also got apply edge detection, some of my other adjustments, but apply Gaussian blur really is taking the brunt of the time here. So let's talk about one of the first strategies. I talked a little bit about, I've got an inefficient algorithm here. This is actually a big O n to the 2 to the power of 2 algorithm. There is a way to get this down to linear time. What my current inefficient algorithm is doing right now is it's going pixel by pixel to apply that blur. You kind of apply it horizontally and vertically. It's doing both of those at the same time. The best way to do it is actually to do 2 separate passes. So you apply horizontal blur and then vertical blur separately. I'm not going to go ahead and rerun the profile, but this is just, it's a faster way of doing things. So the first kind of optimization strategy that you might look for is just an algorithmic improvement. It's getting back to your data structures and algorithms. Am I running these CPU intensive tasks in the most efficient way possible? So that is one thing to look for. Now let's go ahead and run another profile. Pro tip, you can also go ahead and save any of your generated profiles if you are interested. I am a notorious window closer. So if you're a window closer like me, you may want to save. One other thing to talk about is let's go ahead. Let's go back here and let's go, it's analyze inventory. This is going to generate a report. Why am I running 100 times? I'm running 100 times arbitrarily, to be perfectly honest. You want to run enough times to get that representative sample, and that's going to be different depending on your action, how long it runs, how long your individual functions within your action run. Let's go kick this off, and then I'll ramble. So let's record another. There we go. We're recording. Let's let this run. So if you have a long-running action that takes a couple minutes to finish, you probably don't want to run 100 times, right? You'll be sitting around waiting all day for your profile. Maybe just running a couple times, a handful of times is sufficient. If you have something that takes a long time, you probably don't need to do 100 runs. Run it until you think you have a representative sample and you kind of know what to look at, I think is the key here. You should have like a well-defined target and know where to go from the profile. And one other thing I'll mention, we do have a couple docs while this is running. Still going in our guides. Let's stop this. We do have some docs under the development tools section, profiling, that just walks through all of this setup. And we also have a link to Google Chrome DevTools docs that we're using. So if you want a little more information, all the standard node profiling suggestions still apply. Okay, so here we go. So we've ran, you can see the spikes are much smaller, much less well-defined. This is what actually happens when you have a relatively quick running action. The sampler is not necessarily going to catch everything all the time. So if I just zoom in on one of these, so you've got a bunch of little micro bumps there. Hopefully this isn't just garbage collection. So we can see that my run compared to everything else that's going on is actually moving pretty quickly. It is my analyze inventory action, and I can see generate inventory report is a function being called, and I've got a calculate inventory value utility. If I flip down here, one thing I didn't mention, I should have mentioned this for the Gaussian blur, but we can flip back there. This one's actually interesting because apply Gaussian blur is actually near the top, but you can see that idle time is near the top or at the top for my profile here on this, my report profile. I'm not being charged for idle time. Idle time isn't running CPU time, so don't worry about idle as much because you are not being charged. If you're worried about optimizing your Gadget bill, you're not being charged for idle time. You're only being charged for time where your action is actually running. So you can dismiss idle time, which allows you to dismiss a lot of this action run. You can see idle time is the vast majority. Now I can see I do have my generate inventory report. This is from my action. Now I can click on this and it brings me to my actual function here. But you can see as I kind of hover over generate inventory report, you see if I look up top here, it's it's only sampled a couple times. Like things are running pretty quickly here. So this, I would say, is not necessarily a representative sample. Like things are running too fast to really capture a bunch of interesting information about what I might need to optimize. Now it's still near the top, so maybe I still want to take a peek at it, but I'm only sampling it a couple times here in all of my runs. So that's something to look out for. If it's not being sampled a ton, if I flip back to my image generation run and go zoom out for apply Gaussian blur, like I can see it's being sampled on pretty much every run when it's highlighted, which is just not the case for generate inventory report. So that's something to look out for as well. There are also some other views. I encourage you to look at the Google Chrome DevTools docs for those, just to get more information. I find that bottom-up view will probably be the most useful view you use when you're looking at Gadget apps. Okay, so let's pretend that I do want to go ahead and optimize my analyze inventory. If I take a peek through this code, I know that in my run, it is not actually fetching all products, but it's actually generating my report that is taking a bunch of time. And what I'm doing here is I'm doing a bunch of loops through vendors, through products, through product variants. I'm just doing a whole bunch of like, oh, I need all of this information. I need to load it all up into memory and then generate a report from it. There are a couple of good strategies for getting around this. This is a common use case we see, which is why I wanted to cover it, even though it's not showing up as like super sexy on the profile. Gadget has computed views. So make use of computed views when you're doing reports and analytics as much as you can. So even if I scroll up to this like analyze products by vendor, all we're doing is we're creating like a map of our vendors to the products that they have. And we're pulling out things like what's the total inventory and total value. It's really just getting like stock information about products per vendor. Can I do any of this with a computed view? Yes, you probably can pull a bunch of this information either using computed views or computed fields, and it'll just reduce a lot of this looping. It's going to push all of the work down, or a lot of the work, not all the work, a lot of the work down to the database layer, which will means your action should run much faster and you should get those responses much quicker. It should be a lot less burden on your action, and you should see notable improvements if you're using views and computed fields. So that is what I wanted to just mention. Same with my generate inventory report. Like all of this looping where I'm calculating inventory values, which is, once again, it's a utility that's shared. It's called from a couple places here. You can see it's called twice, analyze product by vendor and generate inventory report. I think that's probably a computed field or a series of computed fields or a separate view. So a lot of this looping can be shifted to the database. That is, I just really wanted to mention that. And once again, break your actions and routes up into individual functions because it will make it much easier to profile. It will give you a much narrow scope in which you need to actually investigate and take a look at. I think that's all I want to cover. Once again, we do have some docs here. I encourage you to go through them. It does have a how to take action section. I'm also going to be moving some debugging docs into this section, I think. How does it relate to billing? Maybe this is the last section. So once again, it is CPU time that is being measured. So if you are curious about looking at CPU time, that is total time, like total time. If I look at my run function, my image generation is probably more interesting. Go to the full range here. That is going to correlate to the CPU time I'm being charged, and I'm not being charged for idle time. So when I ran those actions, it did take about 33 seconds, I believe. When I stopped the profiler, more than half of that was idle time. And then run is going to be the other block of time, CPU time, that I'm charged for. Granted that this is divided by 100 because I did 100 runs. So something else to keep in mind if you're trying to look into your CPU time. Once again, this is sampling, so it's not going to be exact. Gadget is getting an exact value. We're hooking into underlying telemetry in our infrastructure, so we are charging you for the correct amount of CPU time. But if you are looking to optimize your bill, this is how you can go ahead and go about doing that. If you have any questions, check out our docs. Ask us in our Discord. Happy to answer any questions you have about this. Also, if you have any feedback for us about things you'd like to see related to profiling or our documentation. We are very interested in improving this, especially if you haven't done profiling before. Anything that we can do to help make this easier for you, we are very interested. So let us know. Until next time, I hope you keep building more and coding less with Gadget.